Good morning. Welcome you all to today's GATE video session. My name is ASHA. I am working as an assistant professor at S.A.ENGG.COLLEGE, Chennai. Today I am going to take about a topic called sorting algorithm, which is present in data structures and algorithms. So before moving on to sorting algorithm, first let me give a short introduction about what is an algorithm. So algorithm is nothing but a step-by-step procedure to solve a given problem. For example, let us consider how to solve a problem for addition of two numbers. So first let us see how to write an algorithm for solving the addition of two numbers. So step 1 we have to start. Step 2 we have to get the inputs from the user. Step 3 we have to add the values present in two variables a and b, and we have to store the output in a variable called c. In step 4 we have to display the output which is present in the variable c to the user. Step 5 stop. So this is the step-by-step procedure which we are following in order to find the solution for addition of two numbers. So while writing or while designing any algorithm, we have to keep two things in our mind. First one is the time complexity and second one is the space complexity. So the algorithm which we are writing, it should satisfy these two things. So the algorithm which we are writing, it should not take much time for execution and it should not occupy more memory space. So this is the overall introduction about algorithm. So first let me say algorithm is a step-by-step procedure or set of rules which is designed in order to solve a specific problem or to perform a computation. It is a fundamental concept in computer science and it forms a backbone of any programming languages, processing data and problem solving. Next we are going to see about the algorithm complexity. So as I told you earlier, complexity in general, it measures the algorithm's efficiency by considering the internal factors such as the time complexity and the space complexity. Such as the time needed to run an algorithm, which is called as a time complexity, and memory space required to execute an algorithm, which is called as a space complexity. So apart from the internal factors, some external factors are also considered, but which is not related to complexity. So they are size of the input of the algorithm, speed of the computer and quality of the computer. So this also determines the efficient writing of an algorithm. So in this slide we are going to see what is time complexity and space complexity. So time complexity is defined as the time it takes for execution of any program or the algorithm. So whatever the algorithm we are writing, it should be very efficient. It should execute in a faster manner. It should not take much time for execution and producing the output. Next one is space complexity. So the algorithm which we are writing, it should not occupy more memory space. It should be an efficient one and it should occupy less memory space. Moving on to sorting algorithm. So in general, sorting means arranging the data items either in ascending or in descending order. So the algorithm which we are writing in order to arrange these elements either in ascending or descending order is called as a sorting algorithm. So the definition goes in such a way that sorting algorithms are the fundamental concept in computer science which is used to rearrange the elements in a specific order. So this order, it can either be a ascending order or a descending order. So there are several types of sorting algorithms are implemented. So they are bubble sort, selection sort, insertion sort, heap sort, radix sort and merge sort, quick sort. So these are the several sorting algorithms which we are using in order to arrange the data items either in ascending order or in descending order. So in this video I am going to discuss about the bubble sort and the insertion sort in detail. First let us see what is bubble sort. So bubble sort is a simple sorting algorithm. So even though there are several algorithms are implemented for arranging the elements in ascending or descending order, this bubble sort algorithm is the simplest sorting algorithm. It repeatedly steps through the list, compares the adjacent elements and swaps them if they are in the wrong order. So how this bubble sort works is by it will compare the adjacent element, and if the compared element is greater than the adjacent element, then the compared element and the adjacent element are swapped. This process is repeated until the list is sorted. So this bubble sort works until the elements are arranged in ascending order or in descending order. This algorithm is named as bubble sort because here the smaller elements are arranged at the top of the list. Next we will see about how this bubble sort works. First start at the beginning of the list. So in a list the n number of elements will be given. So we are going to start from the first element which is present in the list. We are going to compare each pair of the adjacent element, and if the first element is greater than the second element, we are going to swap them. So this process is going to be continued until the list is sorted. Continue until no swaps are needed, indicating the list is sorted. Let me explain this bubble sort with an example. So this is a given list and the elements present in the list are 5, 3, 8, 4, 6. So as you see, we can see that these elements are not in a sorted order. They are in unsorted order. So our aim is to arrange them in sorted way. So in step 1, so all these steps it comes under the iteration 1. So in step 1 what we are going to do, we are going to take the first element which is 5 and we are going to compare it with the second element which is 3. So 3 is the adjacent element present to the first element. So when we compare the elements 5 and 3, we could see that 5 is greater than 3. So as per the bubble sort algorithm, we have to swap these elements. So element 3 will be moved to the first position and element 5 will be moved to the second position. So in step 2 we could see that the elements are swapped. So 3 comes at the first position and 5 comes at the second position. Now we will move on to the third position. So the element which is present in the third position is 8. Now we are going to compare the elements present in second and the third position. So when we compare these two elements, we could see that 5 is lesser than 8. So there is no need of swapping. So when we move on to the next step, we are going to compare the fourth element with the third element. See here, the fourth element present in the list is 4, okay, and the third element present in the list is 8. So when we compare these two elements, we could see that 8 is greater than 4. So ultimately what we have to do, we have to perform swapping. So 4 is moved to the third position and 8 is moved to the fourth position. Okay, the next step. Now we will compare the element which is present in fourth position. Okay, so the element which is present in the fourth position is 8. Okay, and the element which is present in the fifth position is 6. So when we compare these two elements, we could see that 8 is greater than 6. So ultimately what we have to do, we have to swap them. So 6 will be moved on to the fourth position and 8 will be moved on to the last position. And the last elements present in this list is 8. So there is no adjacent elements are to be compared for checking. So we will stop this iteration here. So this step 1, step 2, step 3, step 4, step 5 comes under your iteration 1. At the end of the step 5, we could see that the obtained result is not in a sorted way. See here, 3, 5, 4, 6, 8. So whether the elements are in sorted way? No, again the elements are not in a sorted way because 4 is the smallest element. It has to get present before 5, but here it is not in such a way. So here the obtained output from the iteration 1 is not in a sorted way. So again what I have to do, we have to continue with the second iteration. So this process continues until we get the final output in a sorted way. So at the end of this algorithm, the final output what we will be getting is 3, 4, 5, 6, 8. So this is the output of only first iteration. In a similar way, we have to iterate till we get all the elements in this list in a sorted way. Okay, so the final output will be 3, 4, 5, 6 and 8. Okay, let me tell you some advantages and disadvantages of this bubble sort. So before going into that, this is the implementation part of a bubble sort. See here, for int j is equal to 0, j is less than n minus 1, j plus plus. We are using a for loop. Okay, so inside a for loop, we have to compare the adjacent element. So for that, we are using a if statement if array of j is greater than array of j plus 1. Okay, the adjacent element, we are comparing the adjacent element. So when these elements are greater, what you have to do is we have to swap them. Okay, so for swapping purpose, we are using a temporary variables. So int temp is equal to array of j. So whatever is present in array of j, we are moving it to a temporary variable, and array of j is equal to array of j plus 1. Okay, so again array of j plus 1 element, we are moving it to array of j. Finally, the element which is present in temp variable is moved to array of j plus 1. So this is the implementation part of your bubble sort. Okay. Moving on to the advantages of bubble sort. Okay, so the advantages of bubble sort is it is the easiest algorithm to understand and implement. So bubble sort is one of the easiest algorithm. It is very easy for us to understand and implement. It does not require any additional memory space. So moving on to the disadvantage, Bubble sort has a time complexity of O of n square, which makes it very slow for large data sets. So this bubble sort, it is suitable only for smaller data set items. Suppose if you give n number of, that is if we give large data items, it is very difficult to sort them in a ascending or descending order because it takes a time complexity of O of n square. And here complexity analysis of bubble sort. So earlier slide I told you that whenever we write an algorithm, we have to keep two things in our mind. So first one is the space complexity and second one is the time complexity. So algorithm which we are writing, it should be very efficient in the sense it should take less time for execution and it should also occupy less memory space. So time complexity for bubble sort, it is given in terms of best case, worst case and average case. So in best case it takes O of n. So this means that whenever the array is already sorted, there is no need of swapping. So it takes very less time for execution, so it comes under O of n. In worst case complexity, we are getting O of n square. This happens because here the array is in reverse order. They have given the data items in a reverse order, so it will take some time to arrange them in a ascending order. So it takes a time complexity of O of n square. And in average case also, it takes a time complexity of O of n square because here some elements will be arranged, that is some elements will be in sorted way and some elements will be unsorted way. So it takes a time complexity of O of n square. So these three things comes under your time complexity. And space complexity, it occupies O of 1 because it does not require any additional data structures to be implemented for sorting this algorithm. Next, moving on to your insertion sort. So till previous slide what we saw is all about your bubble sort. Now we are going to see about your insertion sort. Insertion sort is a simple sorting algorithm that works by iteratively inserting each element of an unsorted list into its correct position, a sorted position of the list. So example for insertion sort, we can take it as playing a card. So while playing a card, what we will do, we will split the cards into two. Okay, one is a sorted card, another one is an unsorted card. So what we will do, we will pick a card, we will place them in a sorted way. Okay, so the example for this insertion sort is playing a card. See here, it is like sorting playing cards in your hands. Here we split the cards into two groups. So first one is the sorted card, the other one is the unsorted card. Okay, now we have two cards, one is a sorted card, the other one is the unsorted card. Now what we will do is, we will pick a card from the unsorted group. Okay, so we will pick a card from the unsorted group and we will place them in a sorted group. Okay, it is similar to that of your insertion sort. See here, working of insertion sort. First we will start with the second element, assuming that first element is already sorted. Okay, so insertion sort, it always starts from your second element because we are going to assume that the first element is already in a sorted order. Compare the current element with the elements in the sorted position. So we are going to take the second element, we are going to compare it with the first element. Okay, shift all larger elements one position to the right to make a space for the current element. We are going to insert the current element into the correct position. We are going to repeat this step until all the items in an array or the list are in a sorted manner. See here, let me explain insertion sort with a simple example. So this is a list which consists of data items 4, 3, 2, 10, 12, 1, 5, 6. Okay, so by this insertion sort algorithm, we already assumed that the first element is sorted. So we will leave the first element. We are going to start with the second element. So the second element present in the list is 3. Okay, now we are going to compare it with the previous element. Okay, so the previous element present is 4, which is greater than 3. So what now we will do is, we will swap these first element and the second element. Okay, so see here, the first element now it becomes 3, the second element becomes 4. Okay, now what we will do is, in step 2 we will consider the third element. Okay, so here the third element is 2. Okay, now we have to compare the element on third element and the second element. So third element is 2 and the second element is 4. Okay, when we compare these two elements, we could see that 4 is greater than 2. Okay, so what happens is, so this 2 will be placed at the second position and 4 will comes to the first position. Okay, so see here we'll be getting two intermediate steps. Okay, the first step is, we'll be comparing the third element with the second element. So while comparing, what happens is, 4 is greater than 2, so swapping happens. So 2 will be moved to the second position and and 4 will be moved to the third position. Again, what happens? We have to compare the second element with the first element. Okay, so second element is 2 and the first element is 3. Okay, so while we are comparing, what happens? We will find that 3 is greater than 2. So again, what happens is swapping becomes. Okay, so 2 will move to the first position and 3 will move to the second position. See here, so this is the output after your step 2. See, first position we are getting 2, second position we are getting 3, and in third position we are getting 4. Okay, now we are taking the element which is present in the fourth position, which is 10. Okay, now we are going to compare with all the previous elements. See here, we will compare 10 with the 4. So 4 is less than 10, so no need of swapping. Okay, so we will be moving to the next element, which is 12. So here also what we will do is we will compare the element which is present in fifth position with the element in the fourth position. See here, when I compare it, 10 is less than 12, so there is no need of swapping. Okay, then we no need to proceed to the previous elements. Okay, the next one is, let us take the element which is present in the sixth position, which is 1. Okay, now we will have to compare it with the previous element, okay, which is 12. So when we compare, we will find that 12 is greater than 1. So what we have to do? We have to swap. Okay, so 1 will be moved to the fifth position and 12 will be moved to the sixth position. Okay, again what happens? Now we have to compare 1 with the previous element, which is 10. Okay, so again what happens? 10 is greater than 1. So again here swapping takes place. So 1 will be moved to the fourth position and 10 will be moved to the fifth position. Again what you have to do? You have to compare the 1 with the previous element 4. Okay, so 4 is greater than 1. Okay, so what you have to do? We have to swapping. So 1 will be moved to the third position and 4 will be moved to the fourth position. Okay, again what you have to do? We have to compare 1 with 3. Okay, so 3 is greater than 1. Again swapping takes place. So 1 will be moved to the second position and 3 will be moved to the third position. Right, finally what you have to do? We have to compare 1 which is present in second position with the element which is present in the first position, which is 2. So when we compare, again we will find that 2 is greater than 1. So we have to swap this both. Okay, so the final output at this stage will be 1, 2, 3, 4, 10 and 12. Okay, so this is how we got 1 here. Okay, so next what happens is we have to take the next element, which is 5. Okay, so here 5 we have to compare it with the 12. So what happens? 5 is lesser than 12, or we can say 12 is greater than 5. Okay, so what happens? Swapping takes place. So we have to swap the elements present in 6th position and the 7th position. So 5 will be moved to the 6th position and 12 will be moved to the 7th position. Okay, again see here 5 is there. We have to compare 5 with a 10. Okay, so again 10 is greater than 5, so I am going to swap these two items. So 5 will be moved here and 10 will be moved here. Okay, now I have to compare 5 with the element which is present in 4th position, which is 4. Okay, when I compare, 4 is lesser than 5, so there is no need of swapping. So at the end of the stage, I will be getting the output as 1, 2, 3, 4, 5, 10 and 12. Okay, and the last element to be compared in this list is 6. Okay, so again what I have to do? I have to compare the 6 with the previous element, which is 12. I find that 12 is greater than 6. So what I have to do? I have to swap. So 6 will be moved to the previous position and 12 will be moved to the last position. Okay, again see here 6 I have to compare it with the 10. So absolutely I will find that 10 is greater than 6. So what I have to do? I have to swap them. Okay, so 6 will be moved to the 10th place and 10th will be moved to the 6th place. So swapping takes place. Again what I have to do? I have to compare 6 with 5. So when I compare, I find that 5 is less than 6. So there is no need of swapping. So at the end of this stage, my output will be 1, 2, 3, 4, 5, 6, 10 and 12. Okay, so finally we got all the elements in the list in a sorted way. Okay, so this is how this insertion sort works. Okay, the implementation part of this insertion sort is given here. See here, for int I is equal to 1, I is less than n plus I. Okay, int key is equal to array of I. So we are taking the key element it is present in array of 1. Int j is equal to I minus 1. So we are initializing a variable j and the value assigned to the variable is I minus 1. See here, they have given something here. Move elements of array of 0 to I minus 1 that are greater than key to one position ahead of their current position. So here what they are saying is we are going to take the key element, we are going to compare it with all the previous element in the list. So if the previous elements are greater, we have to perform a swapping. Okay, and the steps are given here. While j is greater than or equal to 0 and array of j is greater than key. So what we are going to do is we are going to swap. Okay, array of j plus 1 is equal to array of j. Again we are going to decrement the value of j, so j is equal to j minus 1. Okay, so this loop it will get executed until the condition is satisfied. So this is the implementation part of your insertion algorithm. Okay, moving on to the advantages and disadvantages. So like your bubble sort, this algorithm it is also simple and easy to understand. It is a stable sorting algorithm. So this algorithm it is also very efficient for all the small list. Okay, so the list which is having small number of elements, for those lists this algorithm is an efficient algorithm. Here space efficient as it is an in place algorithm. Okay, then moving on to the disadvantages, it is inefficient for large lists. Suppose if your list is very large, so at that time this algorithm it becomes very inefficient, not as efficient as other sorting algorithms. So when we compare this algorithms with other sorting algorithms like merge sort, heap sort or quick sort, we find that this is not as much as efficient as those algorithms. Okay, next we are going to see about the time complexity and space complexity of this algorithm. So again here time complexity, they are considering it in terms of best case, average case and worst case. So in best case they are time complexity is O of n, okay, because the list is in already sorted way, so there is no need of comparison. So here the best case the time complexity is O of n. In average case it takes O of n square, okay, and for worst case also it takes O of n square. Moving on to the space complexity, like bubble sort it also takes O of n because it does not require any additional data structures for implementation of this algorithm. Now let us move to the gate questions. So these are some of the gate questions which were asked based on the topic bubble sort and insertion sort. So the first question is, consider the following array 5, 1, 4, 2, 8. After the first phases of bubble sort, what will the array look like? Okay, so here they have given a list with some data items 5, 1, 4, 2, 8. They are asking us after the first iteration what will be the output will be. Okay, so the solution is 1, 4, 2, 5, 8 because we already know that bubble sort works by comparing the adjacent element. Okay, so just compare the 5 and 1. Okay, so first element is 5, the second element is 1. Just compare these two elements. So what happened? 5 is greater than 1. So what we will do? We will swap it. Okay, so 1 will be moved to the first position, 5 will be moved to the second position. Okay, the next what we will do? We will be comparing 5 and 4. Okay, so what happens when we compare 5 and 4? 5 is greater than 4. So we will be swapping the positions present in to second position and the third position. Okay, so it is 1, 4, 5, 2, 8 will be the output. Okay. Second, the number of comparisons in the worst case of bubble sort for an array of size n is, the output is or the solution is O of n square. Third question, suppose bubble sort is used to sort an array that is already sorted. Okay, then what will be the total number of swaps performed will be? Okay, so it will be, the solution is 0 because what I have given in the question is in a bubble sort it is used to sort an array. We know that bubble sort it is used for sorting the algorithms, but if the list is already in a sorted way there is no need of swap, so the solution is 0. Fourth question, which of the following is true about bubble sort? So the options are, it is a stable sorting algorithm, it is not an in-place sorting algorithm, its best case complexity O of n log n, it is more efficient than merge sort for large inputs. So the correct option is A because it is a stable sorting algorithm. Fifth question, let an array of n elements to be sorted using bubble sort. So they have given that array which consists of n elements and we have to sort those n elements using the bubble sort. The maximum number of swaps are required in the worst cases. So the maximum number of swaps which is required in worst cases n into n minus 1 divided by 2. Sixth question, which of the following statements about insertion sort is false? And the options given are insertion sort is stable, insertion sort is adaptive, insertion sort always makes us O of n square comparisons, insertion sort can be implemented in n place, and the solution is insertion sort always makes O of n square comparisons. Seventh question, the worst case running time of insertion sort occurs when? Okay, and the options given are the array is already sorted in ascending order, the array is sorted in descending order, all elements are equal, array has alternating high and low elements, and the solution is the array is sorted in descending order. Thank you. See you in next gate video session.